What is going on, guys? Welcome back to the channel. My name is Jared, and in this episode, since we've tested out the DC system, naturally the next thing is the AC system. Let's go. Back in 2017, I began a full restoration of my 96 Bayliner by tearing it apart all the way down to the hull. From there, I began the rebuilding process, which included learning to fiberglass, rebuilding an engine and outdrive, learning to fare and paint, and even upholstery. Now, I've bought a 28-foot cabin cruiser, and I'm starting all over. Welcome, my name's Jared. Now get ready, because it's going to be a ship show. Shore power cord's in. Let's test it out. Alright guys, so let's talk about the AC system. So we've already tested out the DC system in a previous video, and that worked. A couple of hiccups, but it worked great. So naturally, like I said, the next thing we would want to check is the AC system, namely the battery charging through the inverter. That's why I'm kind of hurrying up on working on this video, because one, it needs to get done, and two, I've been running the battery for the last week or so with the DC system. Minor loads here and there, using the lights when I'm working in the boat, things like that, and it's getting down. It's not low by any means, it's still like 60% stated charge, something like that. But before it gets too low, I want to test out the charging operation. Now it's going to be very limited because I'm only on a 15 amp breaker, or 15 amp outlet rather. So it's going to be kind of limited, but again, I want to check at least what I can. Obviously, I'm not going to be able to test everything because some things are not hooked up yet, like the AC, things like that. But I should be able to test like the microwave, stove. Anyways, let's go ahead and get into it. Okay, sorry for the close-up here, but for the sake of things showing up and really being able to see what I'm looking at here, I put on the kind of telephoto lens. So two things you'll notice right away. One of them is this light here, which was lit up already. That is the house battery on-off switch, or the remote on-off switch, which controls the battery. That's been on, so ignore that. But something new that hasn't been on before is this monitor here. This is the galvanic isolator monitor and test panel. So there's two galvanic isolators behind here for the shore power inlets, and the shore power cord is plugged in, as you saw in that previous clip, and coming in here now I'm seeing that these lights are on, which is a good sign. And not only are they on, but all of the green lights that basically tell you normal operation are on. So there's a test button here, and I can hear relays clicking back there, so it's running through and testing each of the different things that it's looking for, basically. So we have reverse polarity, ground wire connection, and galvanic isolator, and they're all showing that they're working normally, which is awesome news. Now that I know most importantly, the polarity is correct, we can go ahead and flip on Shore Power 1. Shore Power 2 is not hooked up. That's basically, at least it was dedicated to only AC. So if you remember in a previous video, I also rewired this so that it goes through this breaker before it goes to the selector switch. It used to be the other way around, and I corrected that because that's technically incorrect. So the first thing we need to do, flip on Shore 1, and it says power on, and the reverse polarity light is not lit up, which is good, but also expected because of the indicator up there. The other good sign is it turned on and didn't trip, so that means there's no shorts anywhere. At least one drawing more than 30 amps. The next steps here are going to be turning the selector switch to the shore power setting. And that will send Shore 1 to the inverter, not the panel. It's going to go back to the inverter, and then the inverter has AC pass-through, which will actually send it back up to the panel. Again, if you have questions about that, you can go back and watch my previous video. I talk about it a little bit with the AC pass-through and things like that, and the power boost, or power assist they call it. Okay, let's go ahead and flip on the switch, or flip the switch onto shore. That is a good sign. Now, Before I do anything else here, I'm going to go take a look at the inverter and make sure there's no weird fault lights or anything like that, anything going on back there. Okay, so coincidentally, as soon as I stopped recording that last clip, I did hear a big thud back there and a hum. It's like, oh crap, what is that? And then I realized, oh duh, the charger's kicking on, which is good. I just want to make sure everything's set up correctly, which it should be. Oops, let's go back here. So I have the Victron screen display here up so you can see what's going on, even though it is a little bit blurry. Anyways, okay, so you will see that the inverter box says external control. That is because it is currently set up to use the Epoch battery BMS as the controlling device, or BMS, to tell the charger what it needs in terms of voltage and current and all that kind of stuff. The Multi-Plus that I have is capable of up to 120 amps of charge current. However, because I'm on a 15 amp breaker or circuit, if I go into the inverter here, you can see this. I currently have the input current limited to 10 amps. That gives me a little bit of a safety factor with a 15 amp breaker, some long wire runs, things like that. I don't want to trip the breaker. And if there's anything else on that breaker in the garage that could also contribute to that load, I don't want to overdo it. So 10 amps it is. And what that translates to with a 10 amp charge is currently charging at 68, 69 amps, somewhere around there. So a little over half of its capacity, which is still pretty good. So, and again, I don't want to overdo or overtax the circuit that it's plugged in, so I'm going to leave it at that 10 amp limit. Okay, so we are charging, which is awesome. The inverter's doing what it's supposed to do. Alright, sorry for the handheldness here and probably a little bit shaky, but for those of you that don't believe me, there is the inverter. It says inverter on and bulk charging is lit up, so all good. Okay, so with the inverter looking good, checking out, the settings on the Victron display looking good, sweating pretty good, wish the air conditioning worked. Now we're back at the panel. Now we can go down here and switch on some loads at the panel and see what, if anything, even works. Now obviously can't do everything. Water heater, can't do that. If you turn on a water heater without any water in it, that's a quick way to fry it, so we will refrain from doing that one. Microwave we can check, cooktop we can check, AC outlets we can check, battery charger, I don't have one. I should actually get rid of that breaker in here because that is the inverter. Anyways, first thing we need to do up here is I installed a double pole breaker down at the very bottom here. It says AC panel main breaker, so that is actually the feed coming from the Victron inverter back to the breaker panel to feed the loads. So if I do anything up here, nothing will work unless I have that breaker on. I mean, for example, I can try something. Yeah, flip that on, the light doesn't come on, which makes sense because it doesn't have power. Now, if I flip on this lower breaker, nothing exploded. It's always good. I also noticed that my AC voltage gauge just went up to 110, 120 volts. Also good. So, everything's checking out so far. Let's see, what do we want to test first? Figured I'd bring you in here for the special moment. Let's go. I have a laptop charger on here that I had plugged into a extension cord before, so let's plug that in to the AC outlet. That would be a good first test. Nothing crazy would happen if that turns on or doesn't. Okay, AC outlets. Here we go. No light. But it is on. So the outlet seems to be working. For some reason this light in there is not lighting up, so I may have to look into that. And this still needs cleaned up a little bit. I know this is technically kind of dangerous. There's two open holes here where there used to be breakers that I took out, and I will also be getting rid of this battery charger one, or at least changing it to a spare. But yeah, so I'll have to investigate as to why those lights might not be coming on. Okay, but anyway, that one works, which is cool. Okay, what are we thinking next? Let's go cooktop. That's going to require cleaning stuff off. Let's go microwave. Hey, that one lights up. Okay. Moment of truth. Hey, we got 101. Not even close. Let's microwave something. I don't know how to use this actually. Time? 5 seconds? Start. Hey! We're microwaving on a boat. That's cool. Where the heck is the light? It lit up, but I don't even see where it is. Interesting. Maybe it's behind there. Okay. Alright, cool. You have a operating microwave, which is honestly pretty sweet. So, let's clean off the cooktop. Alright, good enough. Open this up. I don't actually know how this works, to be honest with you, so is there instructions? Oh, and if I haven't shown this before, this is a electric / alcohol stove. So you can cook with electric, or if you don't have electric or AC power, whatever, you actually, yeah, there we go. It's actually a reservoir, a canister down there that you fill with alcohol. You can cook with that. It's pretty cool. Okay, back to the thing at hand. Electric. Turn on electric element by depressing the key button, then within 10 seconds the plus button. Depressing, okay. Key, plus. Feel like something should be lighting up. Oh. Never turned it on. You guys are probably screaming at me. Cooktop. Okay. Lights on. Key button. Plus. Hey! Ooh, inverter doesn't like that. I think I feel something happening. Oh yeah. Oh yeah, that's hot. Sweet. We have a working stove. Okay, increase, decrease heat. Oh, nice. There's like 5 settings. Sweet. We have a stove and a microwave. So we can turn that back off. And like I said, that's kind of all we can test right now. Really the only thing left is a water heater, which again, at some point I can fill with water. We can test that out, but that is definitely not a necessity for going boating. That's super cool. Alright, what else can we look at? Alright guys, so one of the other things I want to check on this system before I am happy with it is I want to verify everything back here is good in terms of connections. Now this isn't a full-on stress test of the DC connections, but I am currently charging with about 80 amps. So I did up the input limit to 12 amps on the AC input. So right now it's charging the battery with 80 amps, and it's been doing that for a couple hours now, so I mean it's definitely steady state. So my plan here is, with this old Android phone, I have a FLIR 1 thermal imaging camera. I'm going to go around and point this at kind of any of the hot spots and verify that nothing is exceedingly hot, especially the crimps, the wires themselves, anything like that. So I want to especially pay attention to any of the terminal connections, things like that. So let's fire this thing up, and I think there's video mode on here. Okay. Here we can see the inverter. I mean, obviously pretty warm. Like I said, it's been charging for a few hours, or several hours now. But 38C, definitely a little bit hotter on these AC wires. I think that's actually just because there's a vent opening there, and I think there's a fan blowing some hot air out there, so that's probably why. Again, still nothing frighteningly hot. It's warm, but it's definitely not hot. I mean, this is what, 105 rated cable, so definitely well within its limits, and you would expect it would be, right? Because it's only 80 amps. This next hot spot you're seeing here is the servo. That actually might be the hottest thing I'm seeing so far, which is around 43C. Now obviously this isn't like calibrated, but it's going to give us a good ballpark. I'm actually surprised that those are that warm. It's like it doesn't feel that warm, but I guess the servo puts out a little bit of heat. I guess it makes sense. There's a lot of processor stuff going on inside of there. Okay, so that seems fine. Follow those inverter cables along here. Everything looks good. I'm not going to take the cover off the... Well, maybe I should. Yeah, let's take the cover off. Okay, got the cover off the Lynx distributor. Let's fire up video again. This is probably going to be kind of hot in here. Actually not bad. Being a fuse, I figured fuses tend to get pretty hot, so Just wondering what that would look like, but yeah, not too bad. And again, we're not by any means pushing this at 80 amps, so all looks good there. I'm going to keep an eye on that termination right there. It's getting up close to 40, but no issues. Okay. So keep looking around. Anything else? Again, the Orion XS isn't turned on right now, so I wouldn't expect to see any heat coming from that. That little box there is the Tank GX, and it has an internal power supply that supplies the 4 to 20 milliamp current, so it makes sense that that would be putting out a little bit of heat. So everything looks pretty good back here. Alright, so all in all, I'm extremely happy with the way this thing looks so far as the thermal imaging goes, as far as everything's performing. All the settings seem to be working as expected. I just went through and did a firmware update on the battery, which is kind of a ridiculous thing to say, that you have to do a firmware update on a battery, but it's where we're at in life. That's all good to go. The last thing I'm going to do is I'm going to let this finish charging, let it go through its absorption cycle, all that kind of stuff, make sure that's all working correctly. And then tomorrow, I think I'm going to come out here and really power up this inverter and kind of draw a lot of current. Probably fire up the stove and maybe like a heat gun or something like that. Try and draw close to the 3,000 watts and see what kind of temperatures we get on these cables. Make sure everything's, again, staying within reason. So yeah, I'll let this finish charging and then we'll do that stress test tomorrow. Alright, it is the next day, and the battery fully charged last night. It's actually just charged a little bit now. It's like down to 99, 98%, something like that. Yeah, 98%. So, we are ready to stress test this thing. Got my thermal imaging camera ready to go, and the AC shore cord's disconnected, the shore power outlet's off, so there's no way I'm getting AC power from anything, so everything I do from here is going to be coming from the battery. So the plan is, like I said, I'll probably turn on the stove because that's going to be a pretty heavy draw. We'll see how many watts that is drawing, and then if I need more, maybe I'll get the heat gun, turn that on. Basically high power resistance loads, things like that. I'm going to try and max out as close to 3,000 amps as I can. Obviously, I'm not doing like power assist, which would be putting a little bit more load on it, but I'm purely just thinking about the battery cables at this point. I want to get the thermal imaging camera and monitor all those crimp terminations and all that kind of stuff when it's really pumping a lot of amps through. So let's get the thermal imaging camera set up, get you guys set up, and start turning stuff on. Alright, got the thermal imaging up and running here. So shore power's off, all that's taken care of. So got the inverter ready, and now I just need to turn on the main breaker panel from the inverter and confirming 120 volts. Let's see what I say. We're doing cooktop. See what that does in terms of the initial power draw. So that's drawing about 1,090 watts. Kind of less than I was anticipating, to be honest with you. Well, definitely hot. Okay, so let's leave that going. Okay, I'm gonna need something else, maybe a space heater or something. I'll be back. Okay, got a space heater sitting out here. Obviously don't want it in here because it's already warm enough, so I'm gonna plug this into the outlet. That says 1,500 watts on the back of it, but I have a feeling that's kind of like max. I guess we're only getting 800 watts out of that, so. Alright, well, let's get this on again. It's as high as that goes. Okay, AC loads, if you can see that, probably not, but 1,820 watts, so that's just over half. I guess I could do the microwave, but I gotta put something in it. Alright, let me go get like a cup of water or something. Make myself a nice big cup of tea or something. So let's go, I don't know, 3 minutes. Alright, so that is about 1,800 watts out of the inverter, so this should add almost 1,000. That's going to be up there. It's actually over 3,000 watts right now. This is really putting a full test on it. Like I said, this is, well, 3,200 watts out of the battery. Although it only says 2,600 watts AC, so maybe a power factor thing. I think it's like restricting. It says overload. Let's turn the space heater off. Alright, that inverter's toasty. 40C almost. But the important part is how the wire's looking. Warm. The shunt also kind of makes sense, as it basically is a resistor. but still only 43. I mean, these wires are warm, but nowhere near a problem. All right, microwave's done. Okay, let's leave that go and put the space heater back on maybe. Okay, I'm just gonna let this stuff go for like 10 minutes. Give that a chance to kind of like steady state, equalize, that kind of thing. So I'm not leaving the boat. I don't trust a burner on with nothing on it. So yeah, I'm gonna stop the video here for a minute, just kind of keep an eye on things. Okay, it's getting disgustingly hot in here. Probably been like 10-15 minutes. So let's give this one more check with the thermal camera, see how it's looking. Okay, oh god, it's getting hot in here. I gotta turn this off. Whew, it's hot. Stoves make good heaters. Okay, so after that last clip, finishing up the assessment of everything, there's one last thing I need to do with the AC system, and that is on the breaker panel here. I need to go through and plug these open holes. That's a safety concern. If you stick your fingers in there, you get shocked. And then I need to put on this cover, which is a safety cover that goes over the AC side of the panel. Again, it's a safety thing. It's required by ABYC. I already have it. It was on there. I just didn't put it back on yet because I was making some changes. So still need to put that on. So I am going to measure these and probably end up 3D printing plugs for this because one, I don't know if they even sell anything like that. And two, I have a 3D printer, so it's going to be cheaper. I'm going to get that taken care of, take this panel off real quick, and put that cover on. Okay, well, since that last clip, it's actually been a couple of days, but as you can see, I have 3D printed some little caps that pop in here. They are not perfect, but they should do the job. So I can remove them if I need be, but they're not going to fall out on their own. It prevents people from sticking their dangly bits in there. So this thing's essentially ready to go. I got everything screwed in tight, have that cover on the back that you saw in that last clip. So I think this thing is officially vetted as far as it can be at this point. Again, I can't test the water heater yet or any of the AC stuff because that's not installed, but as far as what is usable right now, it all seems to be working. I do still need to get to the bottom of the light on this AC outlets breaker. I'm not sure why that's not turning on, but that's obviously not a huge deal. For now, I'm gonna just call it good. Okay guys, I think that's going to wrap up this video. That is a huge milestone yet again in the restoration of this boat, getting the AC system working, testing everything, making sure everything's working as expected. Like I said, everything worked awesome so far. I mean, again, can't test the water heater yet and AC, but I did test the water heater at least leak-wise. It's just whether or not the heating elements are functioning as expected and the thermostats, but fortunately those are all pretty easily replaceable pieces if need be. Also getting the stress test done on all the terminations, wiring connections down there is a huge relief off my back to know that that stuff's all performing well under high loads, things like that. Again, I wasn't able to test all the way up to like that 3,000 watt limit for a prolonged period of time, but in what I was able to do, basically running, I think it was just over 2,000 watts or something like that for 10-15 minutes, something like that, and seeing that the wires weren't getting really any hotter at all is an awesome sign. I'm going to continue to keep an eye on those things, but I feel comfortable enough at this point to basically start reassembling the aft cabin, getting the locker, trim, and all that kind of stuff back installed, and moving on to the last couple of items, of which I have several videos in the works right now, so we're working on multiple things at the same time, so keep an eye out for those. So anyways, like I said guys, that's going to do it for this one. Thank you so much for watching. I hope you found this informational, useful, all that good stuff. If you did, don't forget to leave a comment down below. Don't forget to like, subscribe, all that good stuff. And until the next one, thanks for watching.